and we were telling the functional features, okay, mainly the functional features of pneumatic gauging. We were discussing about mainly the functional features of the pneumatic gauging. So with respect to pneumatic gauging, what were the functional features? Can any one of you say what were the functional features of the pneumatic gauging? Can any one of you say what were the functional features of the pneumatic gauging? Karthik, do you remember? Actually, we have done during the last class. The last Tuesday we had a class, which was the last hour. So I have only taken the classes. So after that, since it was an holiday, you don't have any classes. So today morning also I'm starting. So I'm just asking you, do you remember the mainly the functional features which we had discussed with respect to the pneumatic gauging? Karthik, are you available there? Karthik?
Sir,
Huh. So do you remember what are the functional features of the pneumatic gauging?
Formula.
Anyone else?
Rapid response.
Which one? Rapid
Rapid
response.
response.
Yeah. Yes, Asaf. Thank you. Yeah, rapid response. Then anyone else?
No wearing of parts.
Ah, no wearing of parts. Right. Then next one.
Self-cleaning.
Ah, self cleaning of heads and parts. Yeah. Thank you. Yeah, that's
No
what self cleaning
hysteresis.
of. Then
No hysteresis.
no.
No hysteresis.
Ah, no hysteresis. No hysteresis. Okay, Fateh. Then so these were the main the functional features. So today what we are going to discuss is regarding the metrological features. Okay, today we are going to discuss about the metrological features. Okay, today we are going to discuss about the metrological features. I hope so. You can see the slides. So the in the case of metrological features, what happens is non-contact inspection of work parts. It is mainly the non-contact inspection of work parts will be taking place. Okay, non-contact inspection of work parts, then minimum gauging force. Okay, then minimum gauging force, then both variable inspection, that is variability in size, and attribute inspection, go and no go type possible. Okay, so in this case what happens is both variable inspection, that is variability in size, and attribute inspection, that is go and no go type is possible. Then high range of amplification to an extent, that is high range of amplification, then suited for varied inspection such as length, position, and surface topography. These were the main metrological features. The first one was the non-contact inspection of work parts. Okay, first was the non-contact inspection of work parts. Second one was the minimum gauging force. It is always regarding the minimum gauging force. Then both variable inspection, that is variability in size, and attribute inspection, go and no go type possible. This is what. Then high range of amplification, then switched for varied inspection such as length, position, and surface topography. These were the major metrological features with respect to the precision or with respect to the pneumatic gauging. Okay, so in the case of pneumatic gauging, it is like non-conduct of inspection of passes. It is mainly the non-contact of inspection of work parts. Then minimum gauging force, that is the amount of force applied by the gauging force will be minimum, and both variable inspection, that is variability in size, and attribute inspection, that is go and go type possible. So that is even though there is a change in variability, or even though the inspection will be possible, then high range of amplification, to an extent we have a high range of amplification, then switched for varied inspection such as length, position, and surface topography. This is what happens. Then the next name is what name is precision gauging. The name itself defines what it is required for and what is the purpose. Precision means in one word what we can say. What we can say precision means what? Any one of you? Sama, can you tell me what means precision? Mama Sama?
Yes, sir.
Yeah. Can you tell me what do you mean by precision?
Precision. Precision.
We have discussed in the first class, the first module, and the exam also asked the same question regarding precision and accuracy. Yes.
Yes. അറിയില്ല sir.
Okay, not a problem. Anyone else? Anyone else?
Sir,
Rahul, can you tell me what you mean by precision?
Sir, the maximum accurate
Ah, yes. Maximum accurate.
control that an instrument have.
Controlling the instrument. Okay. Nice one. Precision. Okay, just everyone just note it down. Okay, just have a look over it. Okay, I will not explain since I have told you before. Okay, then. Now we are going to start with precision gauging. Okay, so a device used for directly measuring the physical quantities, obtaining measurements indirectly by making calculations on the real world objects in such a manner that one can get the precise values. That one. The mainly the precision is the precise values. That is already we will be having a definite value. Okay, already we will be having a definite value, and with respect to that value, what we will be measuring the instruments and we will check. So already we will be have a defined value. Okay, so we will be having already a defined value, and we will have a cross check regarding the precision. Okay, but what is the precision rate and how much? Okay, and it is always this, it's always restricted to or always related to the tolerance, variable elements, all that. That is the plus or minus of rate. In the case of precision, high length will be 0.00 plus or minus of 1. Okay, 0.00 plus or minus of 1. So it is always the dimension which is very closest to the actual dimension. That's what we say precision. Okay, or it is same as that of the actual dimension. That's what happens in the case of precision. So in the case of precision gauging, okay, in the case of precision gauging, what happens is a device, mainly a device. Okay, a device is used for directly measuring the physical quantities. It is mainly used for directly measuring the physical quantities. It's mainly used for directly measuring the physical quantities. So what are the basic instruments already we have employed for measuring the basic quantities? Can anyone of you tell me what are the basic instruments which is used for directly measuring the physical quantities?
Vernier caliper.
Yes, vernier caliper. Then what else?
Screw gauge.
Oh, yes. That's what you can tell all the experiments which you have already done in the manufacturing technology lab. That's what vernier caliper, screw gauge, everything. So in this case, what happens is a device is used for directly measuring the physical quantities. Here, a device is used for directly measuring the physical quantities or obtaining the measurements, or mainly for obtaining the measurements indirectly by making calculations on real world objects, by making calculations on real world objects in such a manner that one can get the precise values. It is in such a manner that one can get the precise, okay, one can get the precise values. That's what happens in the case of precision gauging. In the case of precision gauging, mainly a device is used for directly measuring the physical quantities. Okay, a mainly a device is used for directly measuring the physical quantities. Okay, a device is used for directly measuring the physical quantities. Okay, then or obtaining the measurements indirectly, or it is obtaining the measurements indirectly by making calculations. It's always by the making of calculations on the real world. That is obtaining the measurements indirectly. Okay, not by manually but by indirectly, by obtaining the measurements by making calculations on the real world, and objects in such a manner that, one can get the precise values. That is one way you want to say one can get the precise values. That is one can get the precise values. Then its its main function its main function on the accuracy and precision requirement. Okay, it has got a main function on the accuracy and precision measurement. Okay, its main function on the accuracy and precision. Then we have the different types of gauges. Okay, then we have the different types of gauges. Okay, include, see, needle gauge, dial gauge, water gauge, stream gauge, and give gauge, and many other gauges are to handy while making requirements in water or air and have uses in the fields ranging from railways to medicine. So this is what happens in the case of precision gauging. Then it can be also be described in dimensions. It can also be described in dimensions, measuring or inspecting. It is mainly the, it can be also be described on the dimensions, measuring or inspecting the tools without a scale to measure any manufacturing parts or elements in order to check the shafts and holes. That's what happens in the case of what, in the mainly in the case of precision gauging. Okay, so it can be also described as the dimensions, measuring or inspection tools where without a scale to measure or any manufacturing parts of tools, okay, or any manufacturing parts of tools in order to check the shafts and holes. So mainly to check the shafts and holes. That's what's the main purpose which we have been used for the requirement. Okay, so that's the what, so that's what the main purpose which has been used for well. So in the case of automatic gauging, okay, in the case of automatic gauging for inspection also happens. So when we are regarding about the precision gauging inspections, what happens is like all these are happening like what, like it is, okay, like it is what, in the case of precision gauging instrument, okay, a device is used for directly measuring. It is always used for directly. It is always used for directly measuring the physical quantities. Okay, one word I can say, it can be always used for directly measuring the physical quantities or obtaining measurements. It can obtain the measurements indirectly. That's why some other source, by making the calculations on real world objects. That's why making the calculations on the real world objects in such a manner that one can get the precise values, in such a manner that the one can get the precise values. Then it is mainly the functions on the accuracy and precision measurement. It's mainly the functions on the accuracy and precision measurement. Then different types of gauges, okay, then different types of gauges are included, that is needle gauge, dial gauge, water gauge, stream gauge, or on other gauges, and many various gauges. Okay, that's what happens, include the needle gauge, dial gauge, spindle gauge, stream gauge, and other gauges, and many various gauges. That gauges are in handy, which is may helps in making measurements in water or air. Automatically the gauges are handy. And what is the main purpose of gauges? Can anyone of you tell me what is the main purpose of a gauges in one word? Any one of you? Amit, can you tell me what is the purpose of a gauge? Amit K. Amit, could you tell me what is the purpose of a gauge? Amit, are you available there? Yes, Amit. What's the purpose of the gauge? Yeah, what? Measure GI. Okay, fine, fine. So now, can you tell me what is the? We can name it as some other tool. We can name it. We can name it as some other tool. Fateh?
No, sir.
We can name it as some other tool. What's the name of the tool? All this we have studied. I'm not asking some from outside or something else. All this we have already told. We have discussed in the class. Some other tool. Okay, okay, Fateh. Now it is inspection tool. Okay, it is also named as inspection tool. Okay, I know some of them are knowing it, but okay. So includes needle gauge, dial gauge, water gauge, and stream gauge on the given gauges, and many more gauges are in handy. In this case, many more gauges are in handy while making measurements in water or air, and have uses in fields varying from railways to medicine, and it also has uses in fields ranging from railways to medicine. Then it can be also be described as the dimension measuring or the or the inspective tool without a scale to measure it, or regarding the respective tool without a spirit tool without a scale to measure any manufacturing parts of tools. It is scale to measure any manufacturing parts of tool in order to check the shafts and holes. That's mainly in order to check the shafts and the holes. That's what happens. Now Now in the case of automatic gauging for inspection, okay, it is also auto. Even the precision gauging and the pneumatic gauging, all this gauging was also used for the inspection and for making the easiness, okay, and always for making the easiness for the requirement of the shaft. Okay, that's what happens. Now in the case of automatic gauging for inspection, okay, automatic gauging for inspection. So just draw this flow chart by the meantime. Everyone, just draw the flow chart by the meantime. Rahul, are you seeing it?
Yes, sir.
Just draw the flow chart. Write the heading as what? What will be in the heading? Rahul. Automatic. Automatic gauging for inspection. അത് എഴുതിയിട്ട് ഈ ഫിഗർ ഒന്ന് വരക്കും. 2 minutes. Okay, I'll wait. Just complete it. I hope so everyone has drawn the flow chart, right? Rahul?
Yes, sir.
Okay. So the topic is like we are going to discuss about the automatic. Okay. Here we are what we are going to discuss is regarding the automatic gauging for inspection. Okay. Automatic gauging for inspection. Okay. So I am requesting everyone soon after our online classes are over, we will be having offline classes. By the meantime, you have to submit your notebook. That's already told. While we while we were having the offline classes. So when you are coming back for the offline class, you have to submit their notebook as well as the meantime. What you have to do, those who have not done well in the series, please write the question paper and submit it. Okay, single time. Those who are not done in the series and those who are absent also, please write the question paper and submit it. Or else from the day the offline classes are starting, you will be not provided with the attendance. Okay, so please note it down and please tell your fellow friends as so many of them are not present in the class. Okay, now in the case of automatic gauging for inspection, okay, and especially those who are not those who have passed the exam, need not write, but rest everyone should write the exam. Who are absent for certain reasons and who are not performed well for certain reasons and everything aspect. Okay, so now we start with the automatic gauging for inspection. Okay, so as a medium, okay, as a medium in the modern industry is adopting high technology manufacturing system. In the case of medium, a modern industry is obtaining high capable of manufacturing system with respect to the automatic. It's mainly respecting to the automatic gauge for inspection. Okay, it's mainly respect to the automatic gauging for inspection. So in the case of automatic gauging for inspection, in the case of automatic gauging for inspection, okay, this what as modern industry is adopting high technology manufacturing process. Okay, modern industries adopting high technology manufacturing process. Okay, manufacturing process such as FMS, CIM, call for integration of production, inspection equipment into fully automated system, all that. As due to the technological advancement, nowadays all the industries are going for high-tech manufacturing system. You can see like with the flow chart what we have done, we are regarding the CNC programming, dry run, trial production, manual offset correction, in-process gauging, okay, production. So what by manual means what? It is like we can have the production then and there and we can change the product. We need not change the product, we can anticipate. Okay, we can already anticipate the product's quality or the product's manufacturing setup or the product's final setup, everything. So we can already anticipate. Okay, to an extent what happens, we can already anticipate the production quality. Okay, anticipate, we can anticipate the product quality to an extent where we have CNC programming, dry run, trial production, then in process gauging and production and manual offset correction. All these factors are under consideration. So in this case what happens is like in the case of automated inspection. Okay, in the case of automated inspection what happens is the modern industry is adopting high technology manufacturing solutions. In this case the modern industry is adopting, okay, the modern industry is adopting high technology manufacturing solutions to achieve high production rate as well as to improve productivity. That's what happens in the case of automatic or automated inspection. So in the case of automated inspection, the modern industry is always adopting high sorry okay, the modern industry is adopting high technology manufacturing solutions to achieve a high production rate as well as to improve productivity. Okay, to achieve a high production rate as well as to improve productivity. The manufacturing systems such as FMS and SIM call for integration of production and inspection. It's mainly the call for integration and production and inspection equipment into a fully automated system. That's what happens in the case of an automated inspection where the modern industry is adopting a high technology manufacturing solutions. Where the modern industry is always adopting a high technology manufacturing solutions to achieve a high production rate. It is always to achieve a high production rate as well as to improve productivity. Then manufacturing systems such as FMS and SIM call for integration of production. Okay, manufacturing systems such as FMS. Okay, manufacturing system such as FMS and SIM call for integration of production. It mainly calls for integration of production and inspection equipment into a fully automated system. Okay, okay, that is FMS means what? Flexible manufacturing system. Okay, then SIM means what? Computer integrated manufacturing. So this is what we say. I hope so you are learning the full form. This all you will be always studying in the CAD cam everywhere. Okay, in the street itself. So in the case of automatic gauging for inspection, the modern industry is always adopting high technology manufacturing solutions. It's always adopting high technologically manufacturing solutions. What is the requirement of high manufacturing requirement? Why do we do all this in order to have high technology manufacturing solutions? What will be the output? Someone can tell me what will be the output if we have high technology manufacturing solutions, or what is the requirement? Someone can you tell me?
Yes, sir.
Uh, Tell me.
To
Hmm. In order to achieve high technology manufacturing solution, to achieve what will we achieve? Finally,
manual errors കുറയും.
hmm?
Manual errors.
Okay. And no, my question is high technology manufacturing solutions is required to achieve what? Errors correct, fine. To achieve,
To achieve
why do we increase production? No, why do we have a high technology manufacturing solution? Why do we require a high technology manufacturing solution? Hmm. Hmm. Why do we require high technology manufacturing solution? Okay, so in order to require high production rate, that was the word which I was expecting. Okay, in order to require high production rate, that's what. Okay,
production
fine, thank you. So, the modern industry is adopting high technology manufacturing solutions to achieve high production rate as well as to improve the productivity. Then, manufacturing systems such as FMS and SIM call for integration of production and inspection equipment into fully automated system. In the case of manufacturing systems, so in the case of manufacturing such as FMS and SIM, okay, such as FMS and SIM, call for integration of production. It is mainly the call for integration of production and inspection equipment into fully automated system. It's mainly into fully automated system. Then an inspection equipment should have an inspection equipment should have electronic control which facilitates pre-programmed tasks and provides an easy interference with the robotic or work cell controller. That's what happens in the case of, okay, in the case of sim call for an inspection equipment should have an electronic control. Always in the case of automatic inspection, an inspection equipment will have an electronic control which facilitates the pre-programmed task. It always facilitates the pre-programmed that task. It's always software. It is built in the inside the equipment and provides an easy interference with robotic or work cell control. And in order to make the understanding easy understanding for the workforce or for the skilled labor, what happens? It has a what easy which facilitates the pre-programmed task and provides an easy interference with robotic or work cell control. It's an easy interference with robotic and voxel controller. The inspection equipment should have the ability to carry out online inspection and segregate good and bad parts of further processing. In this case, what happens automatically we will be having inspection equipment and which will be having the ability, it will be always having the ability to carry out, okay, it will be always having the ability to carry out the online inspection. It will be always having the ability to carry out the online inspection and segregate good and bad parts for further processing, and also segregate good and bad parts for further processing. This is what happens. Then the inspection constitutes the operational part of the quality control. In the case of automated inspection, the inspection constitutes, okay, the inspection constitutes the operational part of the quality control. Then we are basically assessing, okay, we are basically accessing the dimensional accuracy, surface finish, and overall appearance of various components, okay, and overall appearance of various components. So inspection, okay, inspection constitutes the operational part of quality control. In the case of this, what happens? The inspection, the what happens? The inspection, the inspection mainly constitutes. Okay, the inspection mainly constitutes the operational part of the quality control. In the case, inspection mainly constitutes the operational part of the quality control. Then we are basically accessing the dimensional accuracy, surface finish, and overall appearance of various components. So in this case, what happens is inspection constitutes, the inspection mainly constitutes the operational part of quality control. In this case, the inspection mainly constitutes the operational part of quality control. Then we are basically accessing the dimensional accuracy. We are always basically accessing the dimensional accuracy, surface finish. We are always basically accessing the dimensional accuracy, surface finish, and the overall appearance of various compounds Then in a typical manufacturing scenario, it's always in a typical manufacturing scenario. In a typical manufacturing scenario, components are manufactured in large quantities. Okay, in a typical manufacturing scenario, mainly the components are manufactured in large quantities, and it becomes a Herculean task to carry out 100% inspection. What happens is in a typical manufacturing scenario, in a typical manufacturing scenario, components are manufactured in large common quantities. So, in a typical manufacturing scenario, components are manufactured in large quantities, and it becomes a Herculean task to carry out 100% inspection. And it becomes a Herculean task to carry out 100% inspection. In such cases, okay, in such cases, we resort to a statistical means. Okay, in such cases, what happens? We always resort to a statistical means. Okay, we resort to statistical means to an extent where by means of drawing samples out of the population. So This method has a serious flaw. There is always a likelihood of defective parts getting to pass. So this is what happens in the case of an automatic gauge for inspection. In the case of an automatic gauge for inspection, what happens is automated inspection means automation of one or more stages involved in the inspection procedure. So in the case of automated inspection, it means one or more steps is innovated in the inspection procedure. So in the case of automatic inspection, it is already a programmed system where the products gets inspected. Okay, so always where the what happens, the products or the product always gets inspected to an extent where we have the manufacturing process going on, and the manufacturing rate will be comparatively high since it is controlled by the help of the manufacturing solutions. So automatically the production rate will be high, and the possibility and also the possibility of getting the errors are always high. By it might be defect of, it might be the defect of the angle, it might be defect of programming, it might be defect of the wear and tear of the cutting tool, it might be defect of the cutting angle. So many factors has to be considered and has to come in inline process in order to achieve a good product. So what happens is this, there is also many what are many issues, like it can lead to human errors where bad parts may slip through and good parts may be rejected in some human error, because when we are doing the quality check also there will be human errors where the bad parts, okay, so the components the where the bad parts may slip through the through and the good parts may be rejected. So all this has to be considered. So in other words, nothing less than 100% good quality must be tolerated in this case. In this case what happens is nothing in any instant or any case, nothing less than 100% can be considered as good quality or must be tolerated. That's what, that's why we get the second and branded clothes. Okay, branded clothes for seconds. That's what. If any issues has become, they will reject it. Whatever be the any issue, it will be rejected from the lot and it will not be sent for the actual purpose. Not only clothes, whatever be the material. So it becomes second or it gets rejected for the purpose. So the tolerance will not meet the standards. So an higher end system is fully integrated into the manufacturing process. In this case, what happens, a higher end system is always fully integrated into the manufacturing process, and the entire inspection process is automated, and the entire inspection process is always automated. Okay, and the entire inspection process is always automated, then it is able to send the work parts into good and bad, right? That's what into, it is also able to send the work parts into good and bad pieces. That this type of operation is preferred when the process capability is well within the specified design tolerance, and the production is done in large batch sizes. And always when the production is done like, that's what I said in the starting, it is mainly used for productivity, to improve productivity and for higher rate of production. Okay, it is mainly which increase productivity and higher rate of production. So in this case of automatic inspection, we will be having a CNC program. So we will be first checking the CNC program whether it is well placed and no corrective actions has to be made or no updations has to be made or no errors have been done while running the program. Then second one, it is by the dry run. It will be having a dry run to check whether the process, everything is in the exact process and there is no issues like that. Then we will be having a trial production. Trial production means we will be manufacturing a prototype of the product in order to check all the dimension or the all the aspects where it will be coming under the constraint of our measurements, requirements, and it serves the purpose well. Then we will be having in-process gauging. In-process gauging means during the process we will be having gauging that will check whether everything is done right or not. If it is not right, it what happens is manual apps offset correction. Then by with the help of manual tools, what happens? We may correct it or we may modify it. We may check the manual tools or we may correct it or we may modify it. That's what happens like manual. Then we will check whether it is okay or not. Then again we go for the in-process gauging. And in-process gauging is done, and we will make sure that all the process which has done is completed the task, and then we will be sending it for production. Production means always it is a mass production, not a single place production. It's a mass production where continuous availability of the parts will be made by the manufacturer with the help of these machines to an extent, and where will we be having the inspections with the help of gauges and other instruments. The inspection will be taking place, and we will be ensuring the quality of the product which has to be achieved, since it is be used for various other complicated purpose. So this is what happens in the case of an automated, in the case of an automated gauging for inspection, where we will be having a higher end system which is always fully integrated, which is always fully integrated into the manufacturing process, and the entire inspection process is automated. That is also able to set the workpiece into good or bad process. Then this type of operations are performed when the process capability is well within the specified design tolerance, and the production is done on large batch sizes. That is to an extent that happens in the case of an automated inspection. That is the name is automatic inspection for manufacturing process. Then in some cases, with respect to the cases, online inspection is become increasingly popular in an FMS and SIM. And nowadays what happens is we have an online inspection is becoming most popular, especially in the FMS or a SIM moment. I hope so. You remember what I mean by FMS? Can anyone if you tell me? Not anyone. Adarsh Manohar, can you tell me the full form of FMS? Adarsh Manohar, could you just tell me the full form of FMS? Adarsh?
Okay.
Can you tell me the full form of FMS? Hmm. Okay, then Amit, can you just tell me the full form of FMS? What do you mean by FMS? We were telling repeatedly in the case of automatic inspection, FMS. I myself has been told in the class now. FMS. Amit, are you available there? Could you just tell me the full form of FMS? What? Akash came? Yes, tell me. Yes, Akash. Tell me.
Field was that field?
Field? Field? Rahul, could you just tell me the full form of FMS?
Sir, flexible manufacturing system.
That's it. Flexible manufacturing system. That's what I am saying. Okay. And do you remember SIM?
Sir, sim I did get it problem.
Computer integrated manufacturing. Okay. Computer integrated manufacturing. What do you mean by computer? FMS means flexible manufacturing system. Where means what happens? It is quite popular, especially FMS environment. Is why? Because we can have a number of flexible systems to manufacture. In the case of computer integrated manufacturing, that is a CNC problem. Computer means what? We will be having a program which is fed into the computer, and the computer will be doing it, and the computer will be processing it and checking whether it is feasible or not. And finally, by running the computer, we will be the product. Okay. So, what is the difference in computer integrated manufacturing with in the case of lathe? Can anyone of you tell me what's the difference? Srirag Ravindran, are you available there? Srirag. Can you just tell me what is the difference of SIM, computer integrated manufacturing, when compared to normal lathe in the case of automatic inspection?
More accurate, faster.
Yeah, okay, that's all I agree. So, what is the difference when compared to a normal lathe in the case of SIM? Just look on the figure, you will remember. I just a simple question: what is the difference between a normal lathe
Identical.
and SIM? Both are identical. Both the functions are everything is same. Okay. In a manual lathe, what we will be having? What will we having? We will be having a skilled labor in order for putting the material in the chuck, everything. Okay. In the case of computer integrated manufacturing, we doesn't require skilled labor, because why? We have to just feed the part. Then the the computer which is programmed well, or the CNC which is consists of a computer where the program is fed into the computer, will do the purpose and get the product. That's what happens. Okay. That's what we say is SIM, computer integrated manufacturing. And what happens? The automated So all this, so all, in the case of sim, FMS, inline, flexible, all these systems we will be having a what automated. We will be having always an auto. What we will be having automated instruction system in order to check whether the product which we have sent is qualified. No, is checked is quantified, whether it is according to the measurements or according to the standards. That's what for that purpose only we are having an automatic gauging system, which is mainly employed for an inspection system. In the case, it is where do we find this automatic gauging system? Can anyone if will tell me where do we find this automatic gauging system? This automatic gauging system is mainly employed in where? It is mainly employed in the places where we have large production. Okay. So, oh sorry, the time is up. So we'll continue the class in the next class. That's by tomorrow. Okay. Please don't go anywhere. I'll just take the attendance by the meantime. Okay. I hope so. You have drawn the figure, everything. I told to draw a flow chart. Whether you have drawn everyone.
Yes, sir.